Hello guys, my name is Mike Reinhardt and I'm going to be giving you a presentation on recommender systems and the two main types of recommender systems. So let's get into it. So what's on the agenda? I'm going to give you a background of the MovieLens data set, how I prepared the data for analysis, my EDA techniques. I'm going to explain those, the types of recommender systems, collaborative recommender system, and content-based recommender systems. So I'm going to go in depth on what it means and how to apply it. We got the introduction. So the MovieLens datasets are full of data describing how people rate movies. So notice that you saw a dataset. So there are three subtypes of data. Uh, it's they are all in a CSV. It was movies, ratings, and tags. So that's the reason why it says data sets instead of just data. So as it turns out, these data sets have been useful to lots of folks, from recommender system researchers to readers of popular press programming books. It was collected by group lens researchers over various periods of time and by far the most popular when it comes to implementing the recommender system. So I'm not sure how often they actually collect data and update their data sets, because I saw cases where I saw movie date ranges from the 1940s to all the way to 2014, and I thought that was cool how they went back, in the early days to grab movie titles and to grab the ratings from them and to do my analysis on them. So it was pretty cool. Data preparation. So the first thing I did was to read in the movies and ratings data sets. So notice I did not mention tags data set. So I felt that it was not going to be of importance with this particular project, so I did not include it in my analysis. So to your left, you have the ratings data set, which is read in as a data frame. So in the first column, you have user ID, movie ID, rating, and timestamp. And to the right of that is the movies data set read into a actual data frame. The first column you have movie ID, titles, and genres. So notice both of these data frames have one common column between the two. Of course, it's the movie ID. So I merge and combine both of these data frames to output the third data frame that's at the bottom of those two data frames. So in the first column, you have the user ID, movie ID, rating, title, and genres. So I removed timestamp because it was not going to be relevant for my analysis. And there are now 5 columns and 100,000 rows, which y'all cannot obviously see that. And let's go to the next slide. Exploratory data analysis, also known as EDA. So the first things first, I checked for missing values to make sure there weren't any null values that would interfere with my analysis. Then I wanted to see which user had the highest number of ratings. So I grouped by the user and did a count on the ratings. So user 547 had the highest number of ratings with a value of 2,391. And I also wanted to see which movie title had the highest number of ratings. And believe it or not, it was Forrest Gump that had the highest number of ratings with a value of 341. And I did a distribution plot to see the spread of the number of ratings, and the highest rating was 5 and the lowest rating was 0.4. So there weren't any ratings lower than 0.5 or above 5. And the median for the entire data set was 3.5, so not too bad. So let's go on to the next slide. So here's a visualization of a word cloud of the movie titles. So if you don't know what a word cloud is, it's a based off frequency of a given word or character. So the more times a word or character appear in text, the larger the text size will become. Vice versa, if uh, the word or character appears less frequently in text, the smaller the text size will be on the word cloud. So as you can see, night, life, day, man, love was very common in the movie titles. So I thought that was pretty cool to give y'all a visualization of uh, which movie titles, uh, which was appeared common in this whole entire data set. All right, next slide. Types of recommender systems. So there are two types of recommendation systems. The first one is content based, and the second one is collaborative filter. Content-based filtering is works with existing profiles of users. A profile has information about a user and their taste. So the taste is based on user rating for different items. Generally, whenever a user creates his or her profile, uh, recommendation engine does a survey to get initial information about the user in order to avoid new user problem. So for collaborative recommendation systems, uh, is to find users in a community that share uh, the same interests or appreciations. If two users have the same or almost the same rating of items in common, then they have similar tastes. Such users build a group or so-called neighborhood. A user gets recommendations for those items that the user hasn't rated before, but positively rated by a user in his or her neighborhood. Next slide. Memory-based collaborative recommender. So there are two subtypes of memory-based collaborative filter recommenders, user-based and item-based. So the user-based approach, it tends to recommend items to a user which are based on an evaluation of items by users of the same neighborhood with whom he or she shares common preferences. For the item-based approach, it refers to the fact that the taste of the users remains constant or changes very slightly, and similar articles uh, or items build neighborhoods based on likes of users. And afterwards, the system generates recommendations with articles in the neighborhood that a user might prefer. Next slide. Model-based collaborative recommender. So in this type of engine, it involves building a model based on the data set of ratings. So in other words, we tend to extract some information from the data set and use that as a model to make recommendations without having to use the complete data set every time. What this means that in model-based, it doesn't compute the similarities from memory. It's solely based off of matrix factorization or some sort of decomposition to reduce the size of the matrix for like increasing prediction speed and to like avoid overfitting and mainly to for scalability. So some machine learning techniques you can use is singular value decomposition um, and K nearest neighbors, and so forth. So in my particular project, I had used uh, singular value decomposition. Next slide. A content-based recommender. So what a content-based recommender is it tends to make the comparison between the content of items in a user profile. And what I mean by content, the content can be newspaper articles, movie titles, book titles, and so forth. And then the content of each item will be represented as a set of descriptors or terms, typically the word that occur in the document or text. Then the user profile is represented with the same terms and built up by analyzing the content of items which have been seen by the user. Next slide. Don't forget to check out my GitHub for a more in-depth look at my recommended systems I implemented using Python with this particular project. You can contact me via LinkedIn for questions about this project. And thanks for watching this presentation.